Hi, everybody. Welcome. I hope you all had a great lunch break. I'm going to go ahead and jump us into our check in question so we can double check on attendance. Yes, here we are. Just letting a few of us in again. All right, let's get to it. So, here's our check in question. Oh, okay. So, if you could be guaranteed anything in life besides money, or one thing, not anything, one thing in life besides money, what would that be? Be anything in life, but it can't be money, what would that be? So go ahead and put that there into we can double check on attendance. All right, let's take a look here. Ooh, success. Not having student debt, yes. Or having free college. That's another one. Free education. Uh, yes. What else? What else is one thing? I'll put a house for my family. What else do we got? Take substances and be under the influence of them without the harmful side effects. Now that is an interesting take on that. Wow. LOL. All right, what other things will we have? Let's see. Having territory, yeah. Some tacos and some nice. Okay, guarantee one thing: tacos. Free pizza for life. Okay, getting a dream dream job or hot chips. A large successful business. Awesome. Some are like, I don't know. That's okay if you don't know. You could just say you don't know. College admission, that one's good. Oh yeah, just being content with life. Yeah, no matter with what what we have, just being happy. I think that's a good one. All right, Leslie. Yes, that's delicious. Sorry. Admittance into all my dream universities with no tuition. That sounds like a dream. Working well in a job that I would love and that can be successful. Yeah, just having a job you love with success is nice. Happiness. And I don't know who that is, Miles. Playboy Cardi. Is that meeting a person? Oh, he's an artist. Okay, so that's one thing you would like to do. Awesome, awesome. All right, y'all. Hopefully everyone got to share. Some of you shared privately that you weren't certain. That's okay. Let me go ahead and let you know who we have that's not here. So I don't have Tyree. I don't have Jeanette. I don't have Jorge, Ethan, Alacia, Leslie, um, Bianca. That's who I'm missing. So if you're friends of them, if you could please send them a text to come into class. We are having a few more people joining us, but please text them again. Let me repeat. I'm missing Tyree, Jeanette, Jorge, Ethan, Alacia, Leslie, and Bianca. All right, y'all. Thank you so much for participating here in this check-in. Oh, you. Oh, we got Bianca, we got Jeanette, everybody. So yeah, let me fix up this attendance. Welcome to those who just came in. We had a check-in question. Awesome. So let's go ahead and get started, everyone. Let's jump into our agenda. Oh, and we have Miss Walker joining us here today. If you check out the chat, everybody. Hello, Miss Walker. All right, y'all. Let's jump into our agenda. So this is what we're doing. We just had our attendance check. We're going to synthesize the big ideas from the Desmos activity that we did the other day. And yes, you want to take notes in this portion. So please have your binder paper, pencil ready, or if you're taking electronic notes, whatever it is that you're taking notes on, please make sure you have that ready. After that synthesis, please make sure you pay attention because we're going to have like a kind of like an exit ticket. It's not really an exit ticket because it's not the end of the day, but it's a Google form. And again, that's going to be counting towards, your participation. And then we're going to investigate what if we have a curvy rate graph? That's going to be another participation portion. And at the end, hopefully we'll get to the group Padlet. We'll see if we have time for that. As a reminder, asynchronous number 9 is posted and it is due tonight. So please make sure that, you make some time, squeeze some time in there to get that in. Yes. All right. All right, so that's our agenda. Let's go ahead and jump into it. So again, notes, binder paper, pencil, or if you're taking digital notes, be ready. Here we go, everyone. Let's synthesize it. So yesterday, yeah, that was yesterday. Yesterday we did our Desmos, and just as a reminder, we already wrote this down in our notes, but as a reminder, what we were investigating yesterday was the difference between rate and accumulation graphs. And our learning target was I can investigate how rate graphs are related to accumulation graphs. And you were asked to do this both independently and then also with your group. And again, these were the graphs we were taking a look at yesterday. So that was just a recap of what we did. Now let's go into the synthesis. Well, actually, before the synthesis, I'd like to show um, you the reminder of our essential questions. And these were the ones that you were asked to answer in the Desmos as a group. It was number 1, how is the accumulation graph related to its corresponding rate graph? Number 2, how does each graph verify the other? So these were the 2 essential questions you were asked to kind of think about and to talk about with your group. And today we're gonna have some time to get the answers to those, and you will also have some time to individually answer this on your own in our Google form. All right, y'all. So before we jump into our our synthesis of the Desmos activity, I'd like to show you this poster I really, really loved because it kind of, and I took this from, I don't know whose it was. It was someone from this class, right? So I really liked it because it really kind of highlighted all of the big ideas. Now, this one right here, we've kind of talked about when you multiply. For example, we did 50 times 3. This, when you multiply, you get your accumulation graph. So I like how they were like this, and they kind of did like a spiral or a circle, a rotation. They said, well, if you do distance divided by, I don't know what the h represents, but they did division, right? If you divide here, you get your speed. Whoops. I don't know if anyone wants to jump in there or if someone's unmuted. Just mute all for a second. Yeah, so I really love this graph because it kind of, you're answering kind of that second question where it says, how does each verify the other? And we kind of talked about like when you multiply or you find the area of this here rectangle, you get accumulation. Whereas when you divide the y over the x or distance over time, that gets you back to the speed. So for example, here, 150 divided by 3 is 50, which shows up here. And also this group is kind of circled and pointed that out in relation to their table. So that's just kind of like highlighting the posters you guys kind of made yesterday as well, pointing to like our big ideas. So I'm just kind of reminding y'all here, and I really, really like this poster of due to the circular nature and the way that they're kind of showing the answer to that second essential question. So let's go ahead and get this all in writing though. So this was nicely represented in this visual here, but let's go ahead and get the big ideas written down. So again, this is just here for your reference, but here are the big ideas, everyone. Let's please write this down. 1, the total area under a rate graph, that was that speed graph that was horizontal. The total area under a rate graph actually is approximating the total accumulation. Remember, that's distance in our example. Because remember, when you multiply the height of the rectangle and the base, you get the total distance. So that's a humongous big idea there. There we go. And let me go ahead and visually show you that as well for the visual learners among us. So what I mean by area under the rate graph, right now I'm just coloring it in here. And I'm coloring that the area, basically it's the square kind of formed from the line down to the x-axis. Just coloring this in. And maybe let me use a different color. Maybe I'll do text. So again, when you do the height, so in this case it was 50, the height for this graph is 50 miles per hour because that's our units on the y-axis, times the base, 3 hours, is equal to the total distance. And in this case, you all agreed on the Desmos that it was 150 miles. Just notice how that is the area of that yellow portion. It's basically the area of the rectangle. So that's a humongous big idea. The total area under the rate graph gives you the total accumulation. In this case, it gave us our total distance. So that's, make sure we write that down, and feel free to like as well draw this and visualize it for yourself as well. The next big idea. This is always going to be the case. It's huge. Whenever you have a rate times time, that gives you accumulated unit. That's always going to be true. And we're going to be taking a look at different rates. We're not only going to look at miles per hour, we're going to also have different examples of rates that we're going to take a look at. And another way to see the second bullet point right here is basically, let me go ahead and write it right here on the side. Let me change my color. So for example, let me rewrite the way I did the first part where it was miles per hour. I'm going to do this. So it's like, for example, we had 50 miles per hour. I'm writing it like that because that's like the formal fraction way. Because I'm going to show you that something cancels out when we do this. And we multiply by 3 hours. The reason why this gives us total accumulated unit, actually I'm going to rewrite that as the shorthand, hours. Because like that. There we go. Or maybe let me go ahead and post this to the chat if anybody knows. When I set this up like this, do you know what I could kind of cross out when I multiply these two? Maybe if anyone knows in the chat. Oh, okay. Juliana. Oh, and Henry. You both said hours. That is correct. Maybe y'all kind of remember that from like either it could have been from chemistry where you have like the units and you kind of cross off when hours is on top. It's basically like hours divided by hours is like 1, so they cancel out. So these two cancel out. And that's why we end up with 50 times 3 being 150 and our units being miles. So that's a humongous big idea there. And it connects with what we saw in our graphs. That's just an example for you. Let's see what's in the chat. Oh, we didn't have chemistry. Tough, duh. It's okay, but you don't have to have chemistry in order to kind of like visually see this. And you have this graph right here so that you have that proof. That's all right if you didn't have chem. All right, so that was the second big idea. Now let's get to the third. So like I said, I really like that poster that one group did, right? Because it had that kind of like, it told us in the end how accumulation is also related to rate, right? And here's that last part. Some of you, when I was jumping into your group, some of you did say the word slope. So when you were doing distance divided by time, that's the change in y over the change in x. So what you were talking about was slope. The slope of the accumulation graph is the constant rate of the rate graph. So for example, and let me go ahead and color code this. Maybe I'll do red. For example, this here, the slope of this line, it's going to do the rise over the run. So my rise, it's going up by 150 units, or 150 in this case miles. And our run is going to be 3 hours down here. And when you do 150 divided by 3, that's going to get you the 50 miles per hour. MPH shorthand. And again, that's why I liked that one graph, because it went like showing you that it goes back to here and this goes to this, because when you multiply, you get this accumulation graph. So those are basically the big ideas from the Desmos activity. Let's make sure we get those down. I'm also going to pause here for a bit so you could get this down, and also for any questions that anyone might have. And again, what we did here is we answered the essential question a bit, but we're going to take a look at some more examples in a second. All right, so I'm going to go ahead and pause here for a minute, either for questions or for y'all to just finish getting this down. A few more seconds on this slide. And again, these are posted on Google Classroom, so you could go back. I could also send the recording. All right, I'm gonna go ahead and clear this slide, and let's move on to some examples. And again, remember y'all, we're gonna have, we're gonna go ahead and have a Google form to fill out after this, and you wanna make sure that in the Google form, you relate back to our big ideas, so that I could understand like where you're at as far as understanding the concepts of this. All right, so here's some examples, y'all, of some more graphs. So when you're copying this down, just do a sketch. The important thing you need to get down is, first off, like which one's the rate, which is accumulation. When you do your axes, make sure that you put the units. So for example, this one's dollars per hour. See $/hour. This is hours. The accumulation graph here, we have dollars and we have total hours. So let me go ahead and talk about this. As y'all are kind of just doing a rough sketch of it. You don't have to do all the detailed lines or anything like that. So here's another example of other rate graphs with their corresponding accumulation graphs. This right here is a pay rate graph. So in this example, now I know it's hard to see because it's kind of like the line is going through like an in-between here. This is counting up by fives, but if you look at the table, it gives you more information. So basically, you're getting paid $13 an hour. So this horizontal line is intersecting at the y-axis at 13. So this is like that. So here's another example. Again, as you can see, the rate graph with the accumulation graph. Your pay rate is constant, usually, unless you get a pay raise, right? Usually your pay rate is going to be constant per hour. So that's why when you go down on the Y in the table, it doesn't change. You're still going to get $13 an hour. But the accumulation, how much dollars you get, should go up. So again, super essential to pay attention to what the units are. Notice that as the time goes up, so as your hours go up, your rate, your amount of dollars gets accumulated. And I'm trying to make a connection to that word accumulation graph. It's going up. In addition, notice that when you multiply these two numbers, you get the number right here. So for example, 1 times 13, 13. 2 times 13, 26. 3 times 13, 39, and so forth. That's because it connects to our big idea that the area under a rate graph gives you your accumulation. So let me give you a quick little, again, sketch of that as y'all are copying this down. Let me show you, like, for example, in the first, I'm gonna do it in the first 2 hours. We understand that in the first 2 hours, you should be getting 26 bucks if you're getting $13 an hour. But we wanna kind of prove it using our model, using our graph. So what I'm doing is I'm going ahead and I'm coloring in the area under the curve from 0 to 2. And it's kind of hard to see yellow, hold on. From 0 to 2. So the base of this here rectangle is going to be a base of 2. The length is 2. The height of this here rectangle, the height is basically how far up it goes on the y-axis, and it goes up 13 units. So the height is 13. Notice how the area of this rectangle, 13 times 2, gives us $26. It's $26 again because the units cancel. It's a little bit hard to show that here. So this is dollars per hour. I did a dollar sign. And this right here was hours. So again, if you were to multiply these two, you'll see that hours cancel out to give you 26. Similarly, this shows up in your accumulation graph because after 2 hours, if you trace your graph, you're gonna see that you're gonna hit $26. So it all kind of like connects. So this would be at $26. So I'm going to go ahead and pause here for any questions, and also for you to copy this down. Put about a minute on this. All right, y'all, that's our time there for this slide. Let me go ahead and clear this. We're gonna do one more example and then we're gonna have our Google form. So let me clear this up. One more example. And these aren't all the examples. We're gonna take a look at other types of rate graphs. This right here is just to build our understanding and to make connections to our big ideas. Here's our last example that we're gonna take a look at. Now, oh wait, I don't know, Miles. That's an interesting question. But okay, here's another example on the last one before we hit our Google form. So here is an example of hair growth rate and versus its accumulation. So here, hair growth rate, we're making, I think this is more like made up. This is assuming that your hair grows about an inch per month. So this is inches of hair per month, and this is the amount of months. So again, always pay attention to the units. You know that something's a rate when it has that dash, it means division, and you say per in between it. Over here, you have the total inches of hair and then month. Now this is assuming someone has zero hair at the beginning, and then they're starting to grow from zero. So in this here example, again, the growth rate down here is constant. So we're assuming that the growth hair rate is constant. So each month it grows an inch. So it's 1 inch per month. And over time, though, we know that hair gets accumulated. So over time, even though the rate is constant, your hair is still growing. So that's an important thing to differentiate between. All right, let's go ahead and make the connection to the big idea now. Now, the big idea says that the area under a rate graph gives me total accumulation. Let's try this out for the first 3 months. So again, I'm going to use yellow. So in the first 3 months, over here, 3, I'm going to just go ahead and shade the area under the curve. Notice when I do area under the rate graph, sorry, not curve, area under this line, notice that I stop at the x-axis. That's what we mean when we say area under the rate graph. Always stop where the x-axis is at. So you have like a rectangle. Next, we're going to go ahead and check and verify if this, big idea is true here. So the base of my here rectangle is 3 months. So I'm going to write 3 months. Maybe I'm going to shorthand it like this. This means months. Just do that. Our height, well, our height looks like it's always at a constant 1 inch per month. So my height right here of this rectangle is going to be 1 inch per month. So again, this is the base, it's 3 months, and my height is 1 inch per month. Again, let's do that multiplication to see whether the area of this rectangle will give us the accumulation of hair growth over the next 3 months. So we set this up, we go 3 months, base times height, 3 months, that's months. I know it looks really messy. 3 months times 1 inch per month. Month. Let me just add the S so it's the same. All right, so again, we're going to cancel out what's the same, top and bottom. So months will cancel out, and we're going to be left over with 3 times 1 inch. So 3 inches of total hair. I'm going to circle that. And then you verify it. So if you go to your accumulation graph after 3 months, you go up, trace up, 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 and you'll see that it's barely there, kind of gets cut off, but this right here is 3 inches of hair. So again, when you multiply or when you find the area, it gives you the accumulation graph. Let me also write that down. Area of the rectangle gives you total accumulation. Exclamation points. That's just a tremendous connection to our big idea there. So again, I'm going to pause 1 more minute, and then we're going to head into our Google form so that we could kind of process and do some problems like this on the Google form. But this is going to be independent on your own, so we can see where you're at. All right, everybody, I hope you all are ready for our exit ticket. To be honest, I'm very excited to see what your thoughts are, what your understandings are on this. So let's go ahead and jump into that. Well, let's see the chat. Okay, awesome. Someone said they took a screenshot. That's a great idea, to be honest, y'all, for our notes. It's a great idea, and you could take little notes on the side if you're doing digital notes. All right, y'all. So here we go. So we're gonna have about 10 minutes, noise level 0, time to do this Google form. Again, it's going to be asking you to make connections to the big ideas that I showed you on slide 39, but it's also in the Google form itself in case you, or it should be in your notes as well. But let me go ahead and put this in there. And yes, this is unit 3. That's correct. We skipped unit 2, so we're in unit 3 right now. All right. Does anyone have any clarifying questions of the process of what we're going to be doing in the next 10 minutes right now? All right. If there are no questions, we're going to go ahead and get started. We have 10 minutes to fill out this Google form. Again, try your best to demonstrate your knowledge on the big ideas and or any questions you have about the big ideas if you still are like kind of stuck with it. All right. We'll be back in 10 minutes. And please private message me for any issues. We're heading into our last minute. All right, everybody. So we're going to go ahead and come on back. Do make sure you hit submit so I could give you credit for that kind of like an exit ticket of the lesson itself. It's not really the end of our class, but it's kind of like an exit based on what you understand from the big ideas that were supposed to come out of that Desmos investigation. So please make sure you hit enter. I'll be checking these. I'm excited to see your ideas and thoughts about your connections to the big ideas. Now let's move on to our next thing. And we're going to kind of still continue. We're still talking about rates and accumulation graphs, but now something a little bit different. So this actually is nice because somebody in there, let me show you all. Because I was like kind of also taking a look at your answers. And I took a screenshot and just emailed it to myself. There we go. So somebody said in the exit ticket today, there we go. What happens if your rate or accumulation changes with a rapid decrease or increase? In other words, oops, what happens if it's not like a rectangle, right? It's not just a horizontal line. What if your rate is changing? If you think about the real world, we don't always walk at a constant rate. We don't always drive at a constant rate, right? We move at different rates. Like think of if you're driving in a car, you sometimes are going 30 miles an hour, sometimes 35, 33, you know, it's always changing. So the real world has changing rates, right? So I just really liked to bring that in because it leads us, whoever had that question, leads us into our next portion, which is, what if you have a rate graph that's curvy? I just call it curvy, but it's a rate that's changing. So if you look at here, in this here example, I'm gonna have us do a participation check in a second, but let's first take a look at this. So let me first read it and then I'll talk about it. So it looks like this following graph models somebody called Bristol's heart rate in beats per minute. So beats per minute, in your mind you should think that's a rate. Whenever you see the per, beats per minute, so it's a heart rate over time in minutes, okay? During the last 10 minutes of a yoga class. So then you verify, and then at the end, her resting heart rate is 70. So you confirm, yeah, so in the end, after the 10 minutes, it's 70. So it looks like her heart rate, 70 beats per minute. So it's a rate. So I'm gonna put beat per minute. Yeah, I'm failing at that, hold on. T per min. So her rate starts off at 70 beats per minute and it ends at 70 beats per minute. But because this person was doing yoga, the heart rate beat per minute, the rate increased, then it lowered and went back down over the course of 10 minutes. So we have an example here of a rate that is changing. And that's why I kind of titled this is, what if you have a rate graph that's curvy? What do we do then? So what I'm going to ask you all as a class, not in the chat, I actually have something else for you to fill out. Just think about this for now. What are some ideas and what do we do? How do we find, like, how do we apply that big idea of area under a rate graph? So given a curvy graph, how do we find the accumulated unit? That's a big giant question. by the way, in your participation, let's say you don't have any ideas and you're stuck. That's totally fine. If you're stuck, I'd like you to just put a notice or wonder. Totally fine. Let me show you how this participation is going to look like. So it's slightly different. And I'm doing this slightly different because I want to make sure that everybody's included, not just a few of us who are, always participating and so forth. Let me just exit out of this. So for you, I have for period 1, I'm going to put this link into the chat, and then we're going to all open it together as I explain how we're going to do this participation check. So the link is in the chat. I'm going to click along with you. And also another reason why I'd like to kind of collect the ideas and or notices and wonderings in this is because I want to refer back to it. So what you're going to do is you're going to either put your name or initials. So let's say you don't want people to know who you are, just put your initials. I have everyone's roster, so I know your initials. I want you to put down how are ways we could tackle this problem. Any ideas you have, or if you don't have any ideas, put a notice or wonder. Go ahead and take a few minutes to write that in. And we have about 20 students in here, so we should have 20 of these rows filled out. And again, the instructions are up here, so I'm going to keep it up here a bit. So again, if you're not comfortable with your name, put your initials. If you want to use some different name, just text me and remind. If you're uncomfortable, you want to remain anonymous, you could text me and remind like another name you'd like to use. That's totally fine. But I definitely want to give you credit for this. All right, we have about 13, 14, 15, 16, 17, 18, 18. I think we're missing 2 more students, so make sure you're on this doc if you're not yet.
Wait, so are you just writing questions about the image?
Yeah, so for example, great question, Miles. So for example, we basically were able to find the area under a rate graph to tell us the accumulated unit, right? That was in our exit ticket. But now we have something that looks curvy, like this image, this heart rate per minute graph. So it's a rate graph, but it's curvy. So now we have a dilemma. So either you have an idea on how to tackle this here dilemma because it's curvy, how do we find the area of this? Or how will we determine the accumulated unit? If you do not have an idea, put a notice or a wonder. So that's how it'll end up going. Was that clear, Miles?
Yeah, but we have to find the area of the graph.
Well, according to our big ideas, if we go back to the big ideas, the area under a rate graph gives you the accumulated unit. So that was one of our, yeah. So how can we kind of apply this now? Because now we have a curvy graph. We have a curvy rate graph, and it's basically beats per minute kind of rate graph. So, and any idea on how to tackle this problem? If you have it, you're going to go ahead and put it on that doc. If you don't have any idea, that's okay. You could just put in a notice or wonder about this graph. Cool. Let me know if there's any other questions. But definitely, I will be giving credit for this. So make sure that you put in your answer, both this and the exit ticket. And go back to that document. Cool. Let me give you all like 2 more minutes, and then I'm going to go ahead and open this up. I'll put the question over here. And we're going to be taking a look in about 1 more minute. Finish up your thoughts, either a notice or wonder, or some ideas you have about how to tackle if you have a curvy rate graph. How will we determine the accumulated unit? All right, y'all. Let's take a look at what y'all made. Let's see. All right, so let's take a look at some ideas. And it's okay if you're still finishing up some ideas. You can also take a look at what other people are saying as well. So this is more for you than for me, of course. But here we go. All right. Let me read some of these. So we have good question. How would the accumulation graph look like, right? How would it? All right. Heart rate spiked because you watched a scary movie. Maybe during yoga class, they might have watched a scary movie. I wonder if solving, if there's more than just multiplying and dividing. Right. Yeah, because this is curvy. So how are we going to multiply and divide like we did in our big idea? See if there's more down here. Whoops. All right. I wonder if you have to find two different rates. So a lot of wonders, good wonders here. Ooh, this one's a good question. I wonder if we could still use the same way of finding the accumulated unit with the curvy graph. That's a great question. Similar steps or different steps that we use for this type of graph. Someone put IDK. Make sure it's either a notice or wonder. So I want to push you more than just IDK. Try to notice or a wonder is totally fine with me. I love those people who use the black portion of the graph. Y'all are cool. All right, let's see. Let's see if anyone had any strategies. All right, I think we need to find the rate in a specific time. So kind of like, I wonder if you mean like chunking it up or something. Can use/make an equation to be able to find the total amount. Like maybe finding the rates and making it into an equation. Yeah, maybe an equation might be part of it. And then we could use the graph as a straight rate graph and then add additional slope to answer or figure it out. So kind of like thinking of it like a straight horizontal graph and then maybe adding in the curves later. That's a good idea. And then I wonder what we're looking for. Awesome, y'all. So these are great questions and or great ideas. Let me just make sure I didn't see anything different on here. All right, cool. So we're gonna definitely come back to this and we will figure out a way, like how would we determine this? It's actually gonna be the highlight of our unit. It's gonna be the main thing. Yeah, awesome. All right, so let's go ahead and jump into our closure. So I actually had a Padlet activity, but we don't have time for that, so we'll just do that next time. Let's jump into our check out, everybody. So great job on the participation. Thank you so much for it. But here's our checkout. You could either do this via private message to me, or you could do it out so everyone could check it out. But what questions or understandings do you have in general about today's lesson? It could be about the basic big ideas we talked about with basic graphs, or it could be about this new curvy rate graph. So either any questions or understandings. So again, private or out into the public, totally okay. Oh no, try to go to the emergency though, Miles, if you got bit by that type of spider. Oh, someone says, I'm a little bit lost. Okay, thank goodness you're okay, Miles. No questions. Okay, and then I got that someone's a bit lost. That's okay. We're going to build up our knowledge. Yay, understand more of what makes an accumulation graph. I understand that the rate is opposite of accumulation. Yes, that's like hitting calculus right there. An understanding I have is that the area of a rectangle gives you total accumulation. Yes, yes, yes. I understand the correlation between accumulation and rate and how they work together to find each other. These are awesome understandings and or questions or confusions that are coming up. And then we have some people are like, no questions at all. And then I understand the relationship between accumulation graph and rate graph. That's awesome. And then not knowing what to put for an understanding, that's okay. All right, make sure you finish up your final thought there on what questions or understandings you have. All right, everybody. Oh, I want to read this last one. That you can use the area of a rectangle to find total accumulation. I love that. Yes, rectangles are going to be coming up in this unit a lot. You'll see, but yeah. All right, y'all. Thank you so much for your participation, your ideas, your thoughts. It's been a great class. Hope you all have a great afternoon. Bye, everybody. Have a great day. Bye, y'all.
Bye. Bye, Miss Sedona. Bye, Miss Walker.
Bye, Niara. Bye, y'all. I can't hear, but bye. I can't hear you, Tamara, if you're talking, but.